for nature-based solutions for climate mitigation and adaptation. Alongside the UN Water Conference, we're really excited to co-host this discussion with Stanford University's Water in the West program and the Alliance for Global Water Adaptation. Now, EDF's work is centered in climate. We work across the world to cut climate pollution and to build resilience of our human and natural systems to the climate extremes that are already happening. Meeting the climate challenge requires all the tools that we can bring to bear. And to have an impact at the scale that is demanded, we must understand the amazing power of the natural-based mechanisms and then work with them, restoring the natural processes at multiple levels. And this includes many tools that we'll hear about today, like harnessing the capacity of our natural areas to store carbon and leveraging the water resilience that's offered by the incredible natural infrastructure that is our underground aquifers. I really want to thank our presenters and panelists for their important work in improving the understanding of these natural systems and getting the word out, like we are today, about this important set of tools in the climate battle. I thank you for joining us here today, and I will turn the podium over to my colleague and friend, Felicia Marcus, who among all the many things that she's done to advance smart water management is now a Landreth Visiting Fellow at Stanford University's Water in the West program. And Felicia will introduce our panelists in our discussion today. Thank you.
Thank you, Maurice. Thank you very much. I'm looking to see, just to make sure, does the camera being off mean something on that screen that we should worry about?
No.
No, okay. Then thrilled to be here. Thank you for joining us, and thank you to the people who are listening via the Zoom. I know there were a lot of people emailing who didn't make the cutoff for this room, and there are clearly people who are trying to get here and haven't gotten here yet. And so I thank you all for being interested in this topic and for joining us. Next slide. Whoop. There we go. So here's our program for the afternoon. I'm sorry, I'm from LA, so I had to do the Yankee Dodger thing from the program when I was when I should have been sleeping and was Googling images late at night. We're going to start with a spotlight, so a slightly longer presentation and an opportunity to hear from author Erica Gies, who is amazing, who's written Water Always Wins, Thriving in an Age of Drought and Deluge. And so we want to give her time to talk a little bit about what she saw in traveling the world about the nature-based solution space, but water in particular, and the power of water. And it's already inspired many. I've had policymakers and legislators grab me and say, have you read this book? And I proudly have said, why, yes, my friend wrote that book. But I really think that the key to it is that she's written something, because she's a good writer and journalist, but also with heart, that is accessible, and more accessible than the way many of us in the environmental community have a tendency to communicate. So I really value that, and I very much wanted to have an opportunity at this conference, although she's speaking many places, to have a place where people could actually listen to bits of that book for a longer period of time. She'll be followed by Ingrid Timbo, who's the policy director for the Alliance for Global Water Adaptation, clearly the leaders in the space of integrating in water and climate at the global level. And Ingrid knows things down to the local level, but also at the global level. So she'll be giving us that perspective. Then we're going to turn to Scott Fendorf, who is a professor of earth sciences at Stanford and a senior fellow in the Stanford Woods Institute for the Environment, who's completed a really interesting study on beavers and the work that they do that has benefits for climate and water quality. Interesting story how they got there in particular. And then last, but definitely not least, Vanessa Puig-Williams. Did I say that right?
You did.
I meant to ask you and I forgot. Who's with the Environmental Defense Fund in Texas, who's going to talk about the importance of groundwater management from a nature-based solution, nature-based level, as well as a water supply level. And if there's time, I'll talk a little bit more about beavers when we get there. I'll talk a teeny bit about them now. Next slide. Next, just to set the stage, and Ingrid will talk about this more, there's been a revolution in the discussion of nature-based solutions at the international level and the national level over the course of the last few years. It's been amazing to watch how rapidly that has changed with the IPCC report about how we have to deal with land-based emissions or we won't make it, because they're now overtaking fossil fuels because of poor forest management and the outside conflagrations that we're getting. And then that's all resulted in the Biden administration putting billions of dollars into particularly forest management, but also agricultural work to recognize we need to go there. And there's a roadmap for the environment as well. We talked about it more in Sharm el-Sheikh at the COP as well. Next slide. I'm going to go quickly so I can get to Erica. Finally, there are these opportunities, and I did do a paper in last year, finished talking about this integration of climate policy, nature-based solutions, and water benefits across the Colorado Basin states, a big survey, and the area of forest restoration, meadow restoration in particular, and ag land restoration are massive multiple benefit opportunities to be seized. We certainly need to do a number of things to make that happen. And then, of course, along the way, as I said to some folks yesterday, also my funder asked me to look at beavers. And as a lawyer, I cynically went, yeah, beavers. And then I looked at it, I was like, yeah, beavers. So really, at one point, we were thinking this panel would be all about the glory of beavers. But I will say, as I also said earlier this week, that I was in Chile last week, and I started talking about salmon restoration and beavers, and people's eyes opened up, and then they went, you realize they're both invasive species here and very destructive. And I thought, well, it all depends on where you are. You got to know your species and what to restore. Next slide. I think that may be, and these are the key things we need to accelerate. We can talk about this if there's time. You know, a need for much deeper work on quantification of multiple benefits, and at the individual scale that's accessible to policymakers, as opposed to too wonky in the weeds or too Pollyannish above the passion, somewhere in between, illustrative tools that will help policymakers justify funding these things, which have benefits not just for climate and water, but clearly for protecting life and limb and all kinds of other environmental values. Need for far more mapping of the possibilities, and there's work going on that in some places, but also figuring out, leading into Erica, how we tell those stories about how we can save the planet while saving ourselves and our fellow creatures in a way that, again, isn't too misty-eyed, but also isn't too wonky. And I think that is really, these are stories that can motivate and mobilize people and deliver funding to doing these wonderful things that we know are out there to be done. And with that, next slide. Hopefully, I'm going to turn it over to you, Erica, and I'm going to sit over there to give you guys the timing signals.
Okay, do I press this button?
No, you only press it if you want to turn it on. And you say
That's
next
the
slide.
microphone.
That's a microphone.
Sorry, microphone.
Thank you, Lucy. And big props to Lucy Kane, who made so much of this possible.
Hi, I'm Erica Guys, and I'm really happy to be here today. So my book is really about changing the culture of our relationship with water. And in the dominant culture, we have a very control-oriented way of relating to water, and it's really like all about us. What about me? But you know, that's not an innately human way to look at water. There are many people around the world who have a different attitude, who instead of seeing water as a commodity or a threat, they see it as a friend or a relative, and a collaborator. This woman is Madan. She's a marsh dweller, and she lives on the Mesopotamian marshes of Iraq. And she's continuing a 9,000-year-old way of life that gave rise to the Sumerians and has continued. In the 1990s, Saddam drained the marshes in retaliation, and these folks had to go live in cities for the first time. But as soon as Saddam fell, they came back, they broke open the levees, and they returned to their lifestyle, which involves living on the water. They've built islands out of reeds over millennia, over generations. They harvest the Phragmites australis for all of their building materials, and they fish. They have buffalo that they get milk and cheese from. Anyway, during this time in the Mesopotamian area, many great civilizations rose and fell, many agricultural irrigated civilizations. And when they fell, the marshes retook their area and the Medan continued. So I think, there's something, why have they persisted for so long? They accept water, they accept wetlands for what they are, and they recognize the rich benefits that they provide. Next slide, please. So I traveled to many places. This is the British edition for people who might not be North America based. That's the US. I went to China, Peru, US, Kenya, England, India. And in all these places, I met people who are innovating new ways to work with water. And as a journalist who covers climate, I lived through the period of extreme denial and then, well, okay, it's happening, but people aren't causing it. How could we? And now finally, I think it's pretty widely acknowledged, and that's a lot due, unfortunately, to these really extreme water events that we're seeing, a flood and drought that are hitting people where they live. We say that climate change is water change. And just a tiny bit of the science behind that, oceans have absorbed more than 90% of the excess heat that we have released since the 1970s. Warmer seawater evaporates more rapidly, increasing rain in some areas. The warmer air also evaporates more water out of the soil, allows the atmosphere to hold more water. The molecules of vapor are moving more quickly, so it makes them less likely to condense into rain. And so that's why we're seeing these huge deluges. And also while we're seeing it in drier places, it's like a thirstier atmosphere because in dry places it's able to suck more water out of the soil and plants. And water vapor itself is a greenhouse gas. So there's a negative feedback loop as this process happens, further accelerating climate change. So I'm glad that people are paying attention to climate change, accepting it, trying to address it. But I think message that's getting lost that I try to emphasize in the book is that it's not just climate change that's causing these big problems we're having with water. A lot of it has to do with our development choices, and that is urban sprawl, industrial agriculture, and the very engineered concrete way that we try to control water. Next slide, please. So yeah, like when we have flood and drought in the dominant culture, we're like, we need more levees, higher levees, bigger drains, longer aqueducts, doubling down on part of what's gotten us into this problem. But these systems are brittle. And part of it's climate change, part of it's population growth. What might have worked in the past, now we've pushed natural systems to such a brink. We've altered 75% of land on Earth. So these are systems that aren't functioning as intended. And so, these systems are failing more and more often. The single focus solution of like, we're worried about flooding, let's build a levee, we need water, let's build a dam. It ignores the complexity of water's relationships with soil and rock and microbes and beavers and humans as well. There's a whole field called sociohydrology, which looks at how humans impact water availability, which is something that wasn't really considered until recently. It sounds crazy, but it's true. But this problem of our development is also an opportunity because it's something that we can definitely change on the local level. We can come together with people in our own communities to make ourselves more resilient. Next slide, please. Just a few statistics on the scale of our impacts. We filled or drained up to 87% of the world's wetlands, dammed and diverted 2/3 of the world's large rivers, and the land area covered by pavement in our cities has doubled just since 1992. So, we hear about the rise in urban flooding, like this is why, like the water can't get into the ground anymore. So the people I met around the world, I came to think of them as water detectives because they really approach water with a sense of curiosity and respect. And these are engineers, ecologists, landscape architects, urban planners, farmers, community organizers, and they're asking kind of a radical question, which is, what does water want? And basically what water wants is a return of these slow phases, which are particularly prone to our development. So these are floodplains, wetlands, mountain meadows, high altitude forests, and these are places where water slows on the land so it can move underground. There's a lot of important biochemical processes that happen at the base of the food chain. So many great things can happen if we give water space in these areas. And I've come to think of this broadly as the slow water movement. Next slide, please. So like slow food, slow water is unique to each place. It's meant to work with the local geology, biology, and human culture rather than try to control it. Slow water is ideally local. It works to make the most of the water that comes to a particular place. Slow water is socially just. So I think a lot of us are familiar with the idea of, like, if you build a levee, you raise the water level in the river, and that increases flood risk to another community who maybe can't afford a levee. But dams are also a social justice issue. There was a 40-year overview of dams that found that they brought water to 20% of the world's population, but decreased water availability to 24% of the world's population. And even the supposed winners in that scenario are made more vulnerable to the water cycle, because the sociohydrologists have found that when you bring in more water from somewhere else, you just increase demand. It's like when you add lanes on the freeway and then it just attracts more gridlock. So you're just making a larger number of people and businesses vulnerable to the water cycle in a place where there really wasn't enough water for them. Slow water projects are distributed rather than centralized. You know, our current management is centralized, handled by experts. When you think of that 87% of the wetlands that have been eradicated, you begin to understand why we need lots of little small projects scattered all through the water's pathway in the watershed to find places for water to slow and move underground again. And because it's distributed, that brings more people into contact with it. And so in some places I went around the world, people were actively managing it together as a community. In other places, maybe experts are still handling it, but there's educational signage which explains to people what's happening. Next slide, please. So I'm going to talk about a couple of examples from the book. First is in California, and I think people know that California has been dramatically over pumping its groundwater. And, you know, I think many places in the world tend to think of groundwater as extra water, you know, the bank. But in fact, groundwater and surface water are connected. They're basically the same water. And if you have a healthy groundwater table, that supplies your rivers and streams in the dry season. So in the West, actually, a lot of our streams ran year round, which is kind of amazing to people who live there now, because that's just not the case. So it really disrupted the hydrological cycle. And then from a practical perspective, in terms of current management, you know, we've seen all these big atmospheric river storms that California is getting, and people are like, oh, it's being wasted, it's all running to the ocean. And, you know, the reservoirs are full, but in fact, the overpumping has a capacity just in the San Joaquin Valley of 3 times the capacity of California's 1,400 reservoirs. So there's a ton of room underground if we can get the water under there. And, you know, it can, groundwater recharge is an ancient practice. It's practiced by cultures all around the world, including to this day. And California has done it in some places for about 100 years when they had localized groundwater problems. But now the state is looking at doing it on a much broader scale. And one possibility for that, you know, when a lot of water comes at once, it can be hard to get it to soak underground quickly. Next slide, please. So there's a hydrogeologist at Davis. His name is Graham Fogg, and he spent 40 years of his life researching something called paleo valleys. And paleo valleys were formed by the glacial cycles. And in California, those were over the last 1 million years or so on the Sierra Nevada mountain range between California and Nevada. And, you know, the sea level is lower, and the ancestors of today's rivers carved these giant canyons into the soft soil of the Central Valley. Later in the glacial cycle, it backfilled with this cobble and sand, so very, very porous material. And there were 4 major glacial cycles. The most recent one was about 18,000 to 10,000 years ago. And Grant Fogg thinks that those are going to be the most useful because they're close to the surface. They're like 1 to 2 meters down. So the idea is if we find these, then we can set them aside for special recharge areas. And when we get these huge storms, we can infiltrate the water, and then it will flow into the wider area over a longer period of time, raising the groundwater table and helping to heal that hydrology and make more water available for ecosystems and for people. So next slide, please. The process of finding them has been very, very slow and time consuming. The state has now invested in a helicopter method, which is kind of like taking an MRI of the underground. And with it, scientists can create these 3D maps. And it's kind of counterintuitive, but the red is actually the super porous area, the red and the yellow. So, if you are a local agency who's managing groundwater and you have one of these in your area, then you have an opportunity to make a land use decision to set that aside for infiltration. Next slide, please. Then our friend, the beaver. So, both North America and Europe were much, much wetter continents historically before people killed most of them. It's been thought that 10% of North America was beaver-created wetlands. So a much, much wetter, boggier continent that had an incredibly healthy groundwater table as a result. So when all the beavers were killed, or most of the beavers in North America, it really altered the plumbing of North America. So in England, they have been completely gone for 400 years. And in the last decade or so, people have been reintroducing them from Europe. There's a different species of beaver over there, but they function in a very similar way. And interestingly, because people think that beavers cause flooding, in England, they're actually using them to prevent flooding because the beaver dam is it's a leaky dam, right? The water still moves through it, but more slowly. And so scientists have found that they reduce flood peaks by 30%. And that's true even in the winter, even in very saturated conditions. And so there's been a big uptick in flooding of villages along streams in the UK. And they're hoping that the wider spread reintroduction of beavers is going to help with that. Next slide, please. So in the West, starting in Washington state, but now spreading to pretty much all the Western states, people are encouraging beavers to help with the opposite problem, drought. And so, beavers in their ponds store water on the land. And one scientist found that in the first year beavers were introduced to an area, they stored 75 times more water above and below ground per 100 meters of stream than areas without beaver. Now, this is so critical in the West as our snowpack is melting and we don't have that snow releasing slowly into the spring and summer. Beaver ponds are another way to slow water on the land and make it available throughout the year. So, beavers can also heal stream systems that are deeply incised when the stream gets cut down because we've straightened it to try to get the water off the land. It creates fast water. Beavers create slow water. And, we might think it looks messy or mucky, but, what we think of as a natural healthy stream is not. It's this channel with, denuded of trees. And so we need to adjust our culture of what we think is beautiful and functional. And of course, beavers are incredibly important for biodiversity, carbon storage. There's really great studies on that as well out of the West. And they can act as an important fire break. And it's not just that water doesn't burn, but because they're raising the water table across a broader area, the plants are less desiccated, and so they're less likely to burn. Next slide, please. So last, I'll talk about Kenya. This is the moorlands in Aberdare National Park. This is at 13,000 feet elevation. And this is there are 5 main water towers in Kenya, mountains, and a lot of smaller ones. To the point where Kenya has, and they supply almost all the water that everybody downstream uses. This park in particular serves Nairobi, which is 6 million people. And so there's a national agency, Water Towers Protection Agency, that tries to manage them for all Kenyans. And So, there's some science about why mountains are particularly good at capturing and releasing water and giving birth to streams and then rivers. So anyway, in Kenya, they think of these upstream areas as the water generators or the water producers, and then downstream people are the water consumers. I think that's an interesting way to think about it. Next slide, please. And Kenya, like all of Africa, has experienced a really big population growth over the last few decades. And this century, that's where the population boom is happening, from about 1 billion across the continent to 4 billion by 2100. And every government person I met there is wrestling with how to provide water, food, education, and healthcare to people. So a lot of people have been moving into the highlands, cutting trees and farming. So that's a little bit tricky in terms of human rights and finding alternative livelihoods, and they're working on things like that. But I just want to raise, there's a lot of talk sometimes among people who don't know much about it, about trees as carbon sticks, like let's plant pines because they grow so fast and they're going to store so much carbon. But in fact, sometimes people are actually cutting native forests to do things like this. It's really crazy. And I just want to add, there's like a really, really important water component to trees, right? So, plants and their roots help move water underground and infiltrate. In the center of a continent, plants on average create 40% of the rain. So when you have deforestation, you also lose rain. And scientists are still working on various aspects of this, but it's just conventional wisdom in Kenya, because people have seen forests cut and streams drying up within a few years, and so they understand that connection viscerally. So anyway, there are projects in Kenya to restore the forests involving local people. There's a lot of agricultural practices as well, which also help hold water on the land. Can you forward 3 slides, please, to the end? Who's doing it? Yeah, that one. It's a little big. It says slowwater.world. That's my website if you'd like to learn more. And I'll just say, climate change feels really overwhelming, but slow water projects are things that people can do in their own communities with their neighbors. To make their communities more resilient. So it's adaptation for flood and drought, but there's also, of course, an important carbon storage mechanism. Wetlands, for example, can store 3 to 5 times more carbon than forests. So, it's also a mitigation component. So this is an invitation to ask what water wants.
Thank you. Thank you, Erica. And now we'll turn to Ingrid. Next slide. There you go. No more need be said.
I love it. It's fantastic. Hello, everyone. My name is Ingrid Timbo. As Felicia noted, I'm the policy director at an organization called the Alliance for Global Water Adaptation, much easier to remember, AGWA. So maybe, well, first of all, thanks to our colleagues at EDF for hosting us today in the middle of a very busy week for many folks who are in town for the UN 2023 Water Conference, as well as New York Water Week. Maybe just a slight disclaimer at the top, because I am a resident of the Beaver State and a alumna of Oregon State University, whose mascot is the beaver. Go Beavs. I have no expertise related to beavers. I work on global water and climate policy. And so I'm looking forward to the presentations to follow to talk a little bit more about that specific topic. But what I'm going to cover in my short presentation is kind of the state of global action on NBS, and then specifically kind of talk about how water fits into that. So as many of you are probably aware, this whole concept of NBS has really taken off. And last year there were several kind of really big kind of things happening at the global level related to NBS. And the first of that is that there was an actual definition that was agreed to by most, but I will say not all countries related to NBS that happened earlier in the year. And so now there is kind of, because we talk about NBS in a lot of different ways, and actually there are differences regionally, and those are really important. And actually, I was sitting in a meeting maybe last June, and even the countries there were going back and forth. This was even after the definition came out. But it's really big that we do have that. And then also NBS was included in the cover decision language at COP27 in Sharm el-Sheikh, Egypt last November. But again, even there, it was a somewhat contentious issue. They took out the language in several drafts, and then they put it back in, and really nerdy policy stuff. But in the end, NBS was included there. So that was a big win for folks working in this area. Also at COP27, we launched the ENACT partnership, which is jointly chaired by Germany, IUCN, and Egypt. And this partnership is basically recognizing the fact that nature is really sitting at the heart of the biodiversity and climate crises. There are 3 work streams under the ENACT partnership, looking at improving collaboration, because there's so much work going on in different areas and at different levels on NBS. Improving collaboration and coherence between all of these different initiatives. They're looking to amplify and scale existing NBS efforts and also share best practices. And then what they've committed to is every year producing a report featuring NBS in action. So I'm going to actually come back to that in a second, but that was kind of another big thing that came out. And then just after that, in December, the Convention on Biological Diversity finally agreed to the post-2020 Global Biodiversity Framework, or GBF. And that also included NBS for the first time in a CDD decision, and specifically talking about NBS in relation to climate change, DRR, and human well-being. So this is all very, one other thing to mention on that. So actually looking slightly forward for COP28, which will be hosted by UAE, the high-level champion. So there's always each COP presidency appoints a high-level champion for climate change. And the one that the UAE appointed is a woman, Her Excellency Razan Al Mubarak, who is the head of IUCN. So nature is obviously going to be very much a part of their presidency agenda. And also I had a meeting with her special advisor yesterday and talked a lot about what they're thinking about doing around NBS for COP next year. So all things going in a very positive direction. So we feel good about that. However, I'm a water person, specifically freshwater resources management, and what I would say is that freshwater's specific role in NBS is still a little bit limited, and it's also fragmented. And so when we talk about NBS projects, we are often still talking about them kind of in isolation. So looking at like restoring a forest specifically, or or a wetland, or putting in floodplain restoration, and all of these things are great ideas, but we're not really looking upstream and downstream at the impacts that are around that. So we're still not really taking the landscape approach in many or a basin approach, as we would like to say, in many cases. And so I think that's something that we still really need to be grappling with. And the reality is our management systems aren't set up that way. And so there's a lot of good reasons why this is happening. But these are challenges that we now need to kind of think about and grapple with. Similarly, I would say, a lot of the NBS examples that we're talking about are generally either terrestrial or marine, and there isn't a lot of freshwater except for wetlands. We would say freshwater adjacent ecosystems. And so I think, again, the opportunities specifically around freshwater, I think still we need to be kind of moving forward. And then I'm going to finally end by saying, I also think we need to have, I mean, I come from a conservation background too, and I'm really positive on nature, but I think we also have to have a little bit of humility on these things. The way that we hear them talked about, and even in the UNEA definition, it's like NBS is like a panacea to solve all of our problems, and that's actually not the case. And we need to really kind of think very, very carefully about where we are implementing these, where we need to think about green and gray. Or as my colleague from the global engineering firm, Arup, said yesterday, when can we do gray infrastructure that sucks less? And so I think there's a range of solutions we need to be looking for. NBS is one of them. It's very promising, but we need to be considering all of our options. So thanks.
Well said. A lot packed into that. That was
Yeah.
intelligible, impressive. Thank you very much. And with that, we're on to Scott. I don't mean to move them around along so quickly, but I want to be able to get to discussion first.
No, absolutely.
All right, well, I'm going to take us back to beavers, and I want to start off by saying that I am not an ecologist. I'm not a beaver ecologist. I'm actually what we've described as a biogeochemist. So I'm looking at the processes that are happening. And let's go ahead and go to the next slide. My group was really interested in, and we do a lot of work on groundwater. And so we look at near surface processes to kind of the shallow, deeper subsurface, and look at natural contaminants, as we might call them, and sometimes anthropogenic. Part of this work, though, that we were undertaking was in the upper watersheds. And so this is in Colorado. This is the upper watershed for the Colorado River. It's East River. And we're in the higher, as you can tell by it's a really tough place to work, by the way, if you can't tell. So we were in the upper watershed where there's actually not a lot of groundwater. It's very shallow. And what we were interested in, though, is as the rivers move into the lower lying regions and start to slow down, so slow water, you have them going through these meanders. And as you go through the meanders, the water is actually not just moving along the surface river channel, but it actually moves through the meanders as well. And so we were really setting out to look at what is the chemistry and really the biological and chemical processes that then influence the chemistry of both the surface water and the shallow subsurface. So next slide. And we were lucky to have a 5-year period from 2015 to 2020 that we were studying. And it happened to have one of the 3 driest years on record for the last century and one of the wettest. And we were looking at how those climate extremes impacted water through these meanders and what that ended up doing in terms of the biology and the chemistry, microbiology really, and the chemistry, and what that did for water quality. What we ended up happening to find out was that during the low water year, halfway through the season, when the water levels were hitting their minimum points, all of a sudden we had a beaver come in and build a beaver dam right in the middle of our field site. So we had it all instrumented. We were measuring everything that was going on. And if we had said, wouldn't it be great if we could pay a beaver to come build a dam right there? That's where we would have wanted to build. And so apparently it read our mind. And so it came in and built a dam there. And all of a sudden we had a new study going on, which was how do the beaver dams specifically influence the water quality? And I'll just cut to the chase. They completely override any climate extremes. So that the beavers have such a pronounced influence on the water system that it just dwarfs everything else that we see. So next slide. All right, so this is just to show you exactly a meander that we were studying where the beaver dam was in place. All those red spots there are different subsurface sampling where we can measure the water level. We can measure the chemistry that's in there. And so we can see which direction the water is flowing. We can see how fast it's flowing, and we can see how the chemistry changes as the water moves across those meanders. And we can track that against what's happening in the surface water. And you can see where the beaver dam came in right, as I said, right in the middle of our field site. Okay, next slide. All right, so what this ends up doing is that when that beaver dam is put in place, it's obvious that it's storing water on the upstream side, and on the downstream side, it still does, as we heard, is the water trickles through the dam, so that it's still moving. But what it ends up doing with that now differential in water heights is it's driving a lot of the water now laterally. right? And so that's what we call a hydrologic head. And so the graph up here is showing you the hydrologic head across this little stretch of the stream from the top of the meander to the bottom of the meander. And where you see that huge rise, that's the beaver dam. So the beaver dam is causing this big change in water levels between the upper part of the meander and the lower part of the meander, and that drives the water laterally. So what it's doing is it's diverting the water actually through the meander. And so now you pick up all that biology and chemistry of the meander. And it turns out that's a really good thing overall for water quality. There are some exceptions, but by and large, it's a really positive thing. So next slide, and I'll just run through this rather quickly and show you why. So just another view of the ponded water. So you can see the differential in water height, right, and how it's driving the water to the lateral portions. Okay, next slide. All right, so here's what ends up happening. This is before the beaver dam is in place. You see that little arrows there just showing you the water flowing across the meander. It's pretty slow, but you get little bits of signature coming out on the downstream side of the water. Okay, now we get a beaver dam coming in, and I'll just metaphorically show you what happens with the arrows. Next slide. And now those arrows really dramatically increase. So we're driving the water now across those. And what that does is it sets up in essence, that meander now becomes a big bioreactor. So next slide, and I'll just show you in kind of cartoon fashion. So here's our flow of our bioreactor, right? All that water is moving across the meander. Next slide. And what it does is that you have these biological processes that are happening along the meander, coloring slightly off. So what ends up happening is that the first part of the flow pattern, there's lots of oxygen in the water still, and it turns out, just like in our wastewater treatment systems where we're trying to remove things like nitrate or just nitrogen burden from water that can cause ecological problems, and we have excess nitrogen in our waters, typically from agricultural practices. So the nitrogen now drives into this, and the first stage is that if there's any ammonium that's in the water, if you all have fish tanks, you know you don't want too much ammonia in your water, right? So that's why you change it out all the time. Okay, so it drives it to nitrate. That's not necessarily really a good thing, but it sets you up for a second process where in wastewater treatment, the next step you do is you move to an anaerobic where you lose the oxygen, and that happens to be lower in the flow path. You lose the oxygen, and the nitrate now converts to nitrogen gas, or it gets assimilated by the vegetation. And either way, it pulls out of the water. And so what we end up seeing is as that water is flowing across, the nitrate is actually being removed from the surface water. And I should say that during dry years, it actually is being amplified. The concentrations are higher in the surface water during the dry years until the beaver dams come in. And the beaver dams then scavenge out that nitrogen, and you see the nitrogen burdens go down. So next slide. So this is just showing you the decrease in nitrate. So you see when the beaver dams come in, it's a 50% increase in nitrate removal from the water system compared to base conditions. So I won't explain the graph other than to say 50%, right? Okay, and now I'm just gonna wrap up here. So the outcome of this is that beavers turn out to be one of our nature-based solutions that really change the surface water quality. So besides driving more water into the subsurface, they also are improving our surface water quality. And that's really important during these seasonal dry years that we're seeing being more pronounced as we're moving through these climatic changes. So I'll stop there. Thanks.
Fabulous, thank you. One more reason to love them. And I love the way this became the accidental project.
Yeah.
I just think that it doesn't happen all the time, which is terrific. But I'm loving the linkage between beavers and groundwater, and I'm struggling to come up with the metaphor for the policy discussion and policy world. So
Oh, it's infiltrating as well. Yeah. We definitely have infiltration
I
happening.
knew there had to be something.
Before we go on inflation, one thing
Yeah, please go ahead.
I want to say is that this is not the only beaver dam on East River. I should say that they replicate themselves about every half a kilometer to kilometer. And so it's the staging of the beaver dams that really changes the
Is
overall.
that a territorial thing?
I think it's actually a water height thing. So you have to get enough water flow back in for the beaver dams to then come in. So it's really maybe a territorial, but it's really, I think, more of an ecological driver that does it.
No, they are nature's engineers.
Yeah.
They're just geared towards figuring that out.
Yep.
That's great. Well, Vanessa, please.
Okay.
Take it away.
Okay. Well, I'm Vanessa Quigg-Williams. I lead EDF's climate resilient water systems work in Texas. So I'm grateful to be here at this conference, and I've been learning so much. So happy to be here. Okay. Got it. Okay.
Well, that's scary.
Yeah, I couldn't talk without this picture loading because this, I want you to see the picture. But this is the Blanco River in the Texas Hill Country. And I like to show this picture to describe what we at EDF often refer to as the magic of groundwater. And it's what I would describe as a quintessential river in the Hill Country. Its headwaters begin in central Texas, which is where the Hill Country is. And it flows through these beautiful limestone karst canyons and merges with the Guadalupe River and then flows all the way down to the Texas coast. And it's an important source of water for farmers, ranchers, many landowners and communities and wildlife and recreation too. And as we've kind of touched on, groundwater and surface water are connected. So that's why I'm showing a picture of a river to talk about the magic of groundwater, because the Blanco River, like really all of the rivers in the Hill Country and for the most part across Texas and the West is sustained from groundwater. And it actually originates from a spring, which is the picture of the next slide. This is Jacob's Well. It's actually the second largest underwater cave in Texas. And it's the sole source of water for Cypress Creek, which is a tributary to the Blanco River, a pretty important one. And the water that emanates from Jacob's Well Spring comes from the Trinity Aquifer beneath the surface. And the Trinity Aquifer is a really important water supply for many landowners and communities across the Hill Country. Jacob's Well, I think it's just so beautiful. And if you ever get a chance to see it, I encourage you to go when it's flowing. But it's really a window into the aquifer, and it kind of offers a rare opportunity to really visualize the magic of groundwater. And locals often say that it's a canary in the coal mine, and that the health of the aquifer can be measured by the health of this spring. Next slide. But it's not doing very well right now. This is actually a current photo. Persistent drought and increased groundwater pumping in the region have caused aquifer levels to decline, and the spring is dry. It's only happened a handful of times in history. This is happening across the Texas Hill Country right now, across the Western US, and then also across the world, where, as we all know, persistent drought punctuated by flood is the new norm, and groundwater is often the go-to resource for water supply. This is a map of the Trinity Aquifer in Texas, and as I said, it sustains groundwater supplies across the Hill Country, but it's just one groundwater basin or aquifer in Texas. Next slide. There are many across Texas. This is a map of the major aquifers in the state. There's also, many across the US and across the world, as you've seen, that are in decline. Change it. Yeah. So these groundwater basins or aquifers, if we manage them smartly, and if we manage them proactively, provide an incredible valuable tool for resilience of our water supply going forward in an era of climate change. Groundwater management of the past has been passive and reactionary, and we haven't really even paid attention to groundwater that much until something's wrong. And in Texas, we have a saying that groundwater is secret and occult. And I think this is actually true across the world, where groundwater, is largely invisible. And the result is that we have a lack of modeling, we have a lack of data, and that means that we are underinvesting and undervaluing groundwater. So this is what we are working to change at EDF, and we believe that if we start thinking about groundwater basins or aquifers as instead of as natural resources, but as natural infrastructure, then we can unlock the magic and make progress towards a more resilient future. Aquifers are infrastructure, and groundwater, because groundwater basins collect water from many different sources. Erica, I love the pictures in your presentation from your book. So really just shows, how important they are, filtering and cleaning water, storing it below ground where it won't evaporate, and then delivering it where you need it, particularly in rural communities where there may not be another source of water. So how do we unlock that potential? What does it mean? How do we do that? Well, we do it through resilient groundwater management. And so there's really 4 main components to that. First, it means that we have well-resourced and equipped management entities that have strong authority to manage groundwater, and the groundwater sustainability agencies in California are examples. Second, it means that decisions are informed by science and data. Third, communities have a voice in decision making. That's something that we are really focused on at EDF. We have a program in California and in Arizona in partnership with the Rural Communities Assistance Partnership to develop a leadership institute to equip community leaders with knowledge to engage in water management decision making. And fourth, it means that solutions to address sustainability have to be innovative and holistic, and they have to result in multiple benefits. And so that's where I think nature-based solutions play a role. You can't have proactive, climate resilient groundwater management without nature-based solutions. And I would argue you can't implement successful nature-based solutions without proactive, forward-thinking water management in place. And so whether you're talking about building wetlands, keeping land free from development, aquifer recharge projects, beaver dams, which I'm learning more about today, they can be part of a larger management plan that achieves aquifer resilience. Next slide. This slide I wanted to share with you, and the one previous to it is from a group called the Hill Country Alliance, which is a big partner of ours at EDF in Texas. And they're a grassroots organization that's really advocating for the protection of natural resources in the Hill Country. And they've been spearheading a collaborative effort to develop a natural infrastructure plan in the Texas Hill Country. And so as part of this project, they surveyed residents across the Hill Country. And this indicates that the majority of people in the Hill Country really felt like water supply, water quality, and climate resilience were the benefits that they most wanted to see happen as a result of natural infrastructure projects. So I just thought that was a pretty interesting point. Okay, I'm almost at last slide. And then I just wanted to mention that, because I showed that depressing slide of Jacob's Well being dry, that there is a lot of work going on in the local community there to try to sustain spring flow. The Groundwater Conservation District has created a special groundwater management zone and it has adopted rules to limit groundwater pumping in that area. All of that's been informed by data and science about where the recharge zone or spring shed is for the spring, and also a year-long stakeholder effort. And so now they're looking at, beyond just limiting groundwater pumping, what sorts of other solutions they can put in place. Land conservation is a big one because this land, really acts as a sponge. And so I'm hoping that they'll start to look at other kind of nature-based solutions that can be implemented as well. And I'll just end there. Thank you.
Excellent. And we'll move to questions oh, I love that picture.
Yeah,
Thank you for that.
Yeah, that's spring-fed water at its finest.
That's harder to find in California than it is in a bunch of other states. I just have to say.
That's the Nueces River.
Yeah, it's remarkable. Next slide. I just have a few slides as a resource for folks who want it. Since we didn't do a whole beaver panel, but there's a lot of beaver stuff. For people who are actually really interested in it, there are films like Beaver Believers. There are books like Eager by Ben Goldfarb, who I suggest following on Twitter and elsewhere if you're interested. And then next slide.
Felicia, may I add one?
Please.
There's a wonderful beaver book by my friend and colleague Frances Backhouse. It's called Once They Were Hats.
Oh, that's right.
Yeah, and it's more focused on Canada, but it's great. It's a very nice complement to Ben Goldfarb's book.
That's great. Just to give you a sense of landscape transformation, though you saw it. Next one. And then another resource is Dr. Emily Fairfax at Cal State University Channel Island. She is specializing in how beaver complexes provide refugia, fire breaks, sequestration, and more. There are a lot of amazing beaver experts across the country. The woman in, there are a lot of them in Colorado who does all the sequestration. It starts with an M.
Oh, who?
Wall.
I was thinking of
W-O-H-L.
Cherie Westbrook.
Ellen Wall. Yeah,
Oh,
she's
yeah.
great. And there are a lot of good ones. So I recommend if you're interested following her on Twitter. She's very telegenic, but also really brilliant in displaying things in a way that are accessible to people. And I love the title Smokey the Beaver. You gotta really like that. Except you do need to know that it's not Smokey the Bear. It is Smokey Bear. That's very important for our service. But I don't think we need to call it Smokey Beaver because you sort of lose the whole flavor of it. Next slide. Is that the end? Nope. And this is the same cartoon that Erica showed. It's I don't know its original origin. I found it from Occidental Arts and Ecology, and they have been running quite an impressive Bring Back the Beaver campaign. So Occidental Arts and Ecology is another place to deal with. But
It's from California Fish and Game from the mid 20th
Thank you
century.
very much. There we go.
Mhm.
Because it's interesting because they didn't really parachute them that way. They parachute them in crates and then, people, because it was hard to get them where they were trying to move them to go. But sometime in the middle of the century, the pest value of beavers overcame, probably because you do have incidental flooding of fields, and sometimes they do cut down the wrong trees, and they ended up being categorized as predators, which they aren't. And the good news is that the governor has discovered beavers and understands that perhaps that's a problem, that California is behind other states in not allowing moving of beavers, and they've allocated money and staffing, 5 staffers at Fish and Game. So we'll see some real policy changes in California, which is great. Next slide. Great. And now we can go to discussion and Q&A. I have a few, but I want to start in the room. And do we decide you can get them on the?
Yeah, we don't have any.
We don't have any yet. Okay, great. From the because there are more people online than in the room. Are there any questions in the room? Say who you are if you don't mind.
Yes, Matthias Görres, I'm with German Development Corporation. I'm working with Ingrid on several issues, especially on international solutions. I was wondering, sorry, I'm in introduction, so I don't know your names. I'm Erica and Ingrid. The campaign that you had in the field, I was wondering, apart from the matter flux that you measured, like what does it mean, for example, for climate gases? So would there be emissions involved, and how does biodiversity change if you made any measurements or on that? And another question would be, if there's time, there was a presentation last night by the German on climate impact research with the new study on how climate systems are linked worldwide, and what that means for rainfall patterns, for example, and how groundwater recharge next to that. Would you consider the agriculture desert of the Midwest to be also a reason for those aquifers that we are working with not to be in the state that they used to?
Make it more difficult. If you're going to answer a question up here, can you try to reiterate it for the people online?
Yeah.
Featuring us, it might have been hard to hear.
Yeah, because there's just 2 mics up here. And they're not
Oh, all right.
So do your best.
Okay.
That would be hard. I am so sleep deprived that now I don't remember the first. Sorry.
I think I can
Yeah,
capture
I think
that.
now I remember it. Okay,
Yeah.
got it.
So just for introductions, I'm Scott Fendorf. I'm a professor at Stanford. And the question was, well, there were a few towards me. The questions in there were, in part, what were the ecological changes, and within that, what were the potential changes in greenhouse gas emissions from the beaver dam emplacements? And so I'll say that it's a complex discussions because you get both nitrous oxide and methane, slight increases. Nitrous oxide, not as much because it tends to be it's when it's more cyclic that you see the nitrous oxide. So you get a little pulse at the beginning, but not too great of amplification compared to what you have from the meanders anyways. you get a little slight increase in methane production through it, but you also are getting greater carbon storage because of the increased overall conditions of the wetland. So by and large, it's actually a decrease in greenhouse gas emissions on the overall cycle rather than an increase, even though you trade off which gases are going. So in terms of the overall ecological change, over the course of the study that we have, we don't have a long enough duration to really capture that. We can see in the microbiology, we can see slight changes because again, you have change in the aerobic to anaerobic zone. In terms of the above ground vegetation, we don't have enough long enough history to really see a major change there. So, and in terms of the rest of the biota, I can't say. So turn over to Vanessa.
Can you repeat your question one more time? I think were you asking about the Ogallala aquifer and the mining of that by agriculture use?
For example, but also I'm not sure, like, I mean, I know that northern Texas leaves agricultural use from agricultural use and also with the ranches or the cattle on the basically on the land use pressure. Does it also affect the aquifer that you are working?
Oh, okay. I see what you're saying. Well,
repeat the question.
Okay, so the question is about whether the agricultural production that's occurring in the high plains of Texas is connected to the aquifer that I was talking about in my presentation, which is the Trinity aquifer. And the answer is just, the short answer is no. I mean, those are separate aquifers. And we're at EDF in Texas are working primarily in the Hill Country and in West Texas because we are right now focused more so on groundwater surface water connections. And there aren't a lot of those anymore in the high plains where the Ogallala aquifer is, unfortunately, because that aquifer in Texas and then, up into the Midwest is being mined. It was interesting when I was listening to you talk because I just finished reading this book called The Worst Hard Times by Timothy Egan. And
Amazing book.
Yeah, it's really good. And, just that it was making me think about how all of the grasslands that were destroyed so quickly to plant wheat, how could that have actually had an effect on rainfall patterns? Because, that was, then that happened and it just stopped raining for so long.
I've been thinking that too, like there was like the rain followed the plow, but in fact, the drought followed the plow.
It did.
I think there's something to that. Yeah.
But anyway, that the high plains and the Ogallala aquifer is a complicated system, and ultimately that water isn't really going to be available for farming. And EDF's doing some really good work in California on land repurposing, and I feel like that's probably something that a lot of the high plains farmers are going to need to look at, and hopefully at some point there'll be some larger conversations about that.
Other questions in the room? Yeah, this
I'm Jenny Davis. I did not know all of these wonderful things about beavers. So I've learned a lot, and I'm ready to join the fan club. But it makes me wonder who's not doing the fan club. So who would be the groups that are not jazzed about supporting more beaver dams, more whatever, and how does anyone have any examples of how those issues have been negotiated?
I can answer that.
Yeah.
Yeah, so often farmers or landowners might think that they don't want beavers, often because, maybe favorite trees are felled or something of theirs is flooded. There are people who are kind of working toward détente between beavers and people, which might reduce the level of a beaver's pond so that not as much of the land is flooding. But more often you see that these landscapes are so degraded, and if a beaver comes back in and then the farmer, let's say, or the livestock person sees that their water table is raised and that there's more water on their land for longer throughout the year, then they become converted, and then they share with their neighbors, and that becomes converted too. There are actually a lot of beavers in cities as well. I looked at Seattle, And there was a study done by a couple of scientists there a few years ago, and they found them in like pretty much everywhere they look, like 55 different locations within Seattle. You know, beavers aren't really afraid of us. Like, you know, one had a dam near a Walmart parking lot or by a freeway. So they're okay living near us if we're okay living near them. And so that scientist, Ben Dittbrunner, who was one of the founders of Beavers Northwest, he talked about like, you know, a lot of the places beavers go in cities are parks. And so, you know, park designers need to think about how can we design our park infrastructure so that beavers coming will enhance it rather than degrade it. So, you know, don't build a super low footpath that's going to flood, you know, build it higher up, or, you know, plan for them coming and plan so that when they do come, what they do is an add-on. And in some cases, like in a city, you know, beavers do cut down trees in an area and then they move to another area. So people are planting more willows for them, and, you know, like maybe putting chicken wire around favorite old trees so that they're not, yeah. So there are various ways to work with them.
We can do a field trip to Martinez, because Martinez Beavers is like the one of the urban beaver websites with a lot going on, and Heidi Perryman is a real sort of cheerleader in the beaver world. There's a beaver summit in California that happens every other year. I think there's a lot going on. Some of the other things that policymakers have done who have see the value of beavers, but are trying to acknowledge challenges, you can indemnify farmers. If you're like, for example, there may be something California does in reintroducing beavers, you just say, well, if this part of your field gets flooded, we'll indemnify you for the loss. So some of it, it requires intervention and constant care. But yeah, I encourage you to watch one of those. I can get you the links for beaver believers and all of that. It's sort of amazing to discover.
Hi, I'm Daniel Smith from Virginia Tech, and part of my question was answered. I was thinking about the role of beavers in urban environments. So a lot of the pictures that were shown, a lot of space, a lot of things to move around, and a lot for the beavers to do in those areas, but in those combined urban environments. I was just wondering what research is out there that shows either benefits or non-benefits to either water quality, water quantity, and those type of parameters. And so part of that was already answered. If you could elaborate on more of that, what it is out there, I'd be very curious. Thank you.
Well, so that study that I was talking about in Seattle, Ben Dittbrunner was one of the, I think he was the lead author. That's Dittbrenner. I don't remember the journal off the top of my head. I think it was maybe circa 2019 or thereabouts. You know, beavers go through a succession regime typically. So, you know, they do cut down a lot of trees. Now, willows, when they bite them, they resprout in every area. So it becomes very dense and it kind of like responds to the beaver and regenerates. And that's one of their favorite foods. But sometimes they do cut down all the vegetation in an area. Sometimes their ponds silt up over time. And so in a city environment, if it was a park, for example, that might be another way where park managers are going to be dredging that silt periodically so that they're, or maybe just allow them to move on. And then, you know, later they move back once conditions change back to something that's favorable to them. So it depends on the situation and what humans need of that particular park. But Ben's point is like, if you plan ahead for them coming, because if they're in your area, if you have something that's like nice and beavery, they're gonna come.
Can I just add on one part that one of the things that we already mentioned that beaver dams do is that by essentially diverting the water out into the peripheral regions, it's increasing the natural bioreactors that are there. And so you're tending to see overall much better water quality when you have a beaver dam that's migrating water off. They're just kind of digressing for a moment. If you look at the Mississippi River and how it's been really channelized, that's in that along with the land use above and the upper parts of the watershed are the problem. But it used to be that you would have, if you brought nutrient loads down the Mississippi River, they would come down, they would divert off into the lowland regions, the flood regions, and then you would have ecosystems that are pulling those nutrients out that we now think of as contaminants. Now we just move them right on down to the Gulf of Mexico. So in kind of a smaller way, when you think about urban settings and you have these rivers that are during low water flows and they're being dammed up, that's actually really improving the overall water quality in general. There are some exceptions, but in general, it's a positive.
I think one of the things I liked about your paper is that it made things accessible about water quality, because generally the worlds of the people who do water quality and the people who do water supply or even ecosystem management are different.
Yeah.
I've been in both worlds, or different worlds and different people, and many people don't realize the power of bioreactors, may not have heard of bioreactors, but it's what we technically at the State Water Board would call the magic touch of nature, because it really does work. And we would fund projects depending on the contaminant. Obviously, it doesn't work for every contaminant, but those of us who worked also in the natural resource work really don't understand the water quality aspect. So it was particularly accessible even for a non-technical person, which I thought was particularly good.
And even just like as a point of reference, I looked at another project in Seattle where they restored the hyporheic zone under a stretch of creek, which is kind of like the gut microbiome of the stream and very important for stream health. And they did a study afterward to see how much that was cleaning. But first they measured all the pollutants and urban runoff. So you think of all that water that's not soaking in the ground, it's just like running across pavement and like dumping into the creek really fast. They measured more than 1,900 different contaminants. So these are things like lawn fertilizer, brake pad dust. This is really typical of our urban environments. And none of these are regulated because they're non-point source pollution. So yeah, beaver dams or the hyporheic zone, like in this particular study, they found that a packet of water that spent went 15 feet in the hyporheic zone, spent 3 hours in the ground, 78% of the chemicals were reduced by at least half.
That's why a lot of the modern stormwater permits, even in the urban setting, the MS4 permits, allow extra time or credit for land infiltration, the 85, absorbing the 85% storm, because so many of those contaminants that are found can be neutralized in some ways through just sinking it into the ground, which is kind of amazing. Amazing if you think about it. Now, Ingrid, all of this stuff you were talking, it was interesting because you're taking notes. You were. There's a quiz now for you. You were talking about this distinction between talking about MBS and talking about water, and also being overly simplistic. To what extent do these kinds of conversations come in at that global level? How is it talked about? I've been at IUCN meetings. I've been at other meetings where people will, and I'm guilty of this, talking about sort of in glowing terms, this magic touch of nature, the importance of the multiple benefits, and this shift in thinking about how to blend gray and green infrastructure. It's not all one or the other. But I mean, to what level do you see the conversation getting, to the local level, to an actionable level, and to what extent do you see that international conversation having an impact on what happens on the ground?
Yeah, so I would say most of the action is all of the action is happening on the ground. I mean, it's all because all of these solutions are very localized to the place where they're being implemented, and so there is a lot of action that's happening, and that's actually what's kind of bubbled up, I would say. Now, coming from the opposite end, yes, we are seeing, these agreements and all of these sorts of things kind of referencing nature and how important it is as a climate solution. Where it's still percolating maybe is at kind of going from the global level to the national level. And I think that is where, because that's where they have to actually grapple with how do we think about this at a national planning scale. And there are so many complicated different jurisdictions and components that need to be involved in that. There is some of the countries are doing this, like Chile, for example, which you mentioned, and we refer to this in the policy world as mainstreaming. So they are mainstreaming NBS in their climate plan. So under the Paris Agreement, countries make a national commitment, which is called an NDC, nationally determined contribution. And so in these plans, what Chile has decided to do is they have stated in their updated version, which was in, I think it was last year, 2022, that all of their mitigation and adaptation commitments have to include that NBS has to be at least considered as an option across all of their different commitments. And so that's a way where, again, it's not going to be taken up in everything, but in their commitments on energy and agriculture and forests and whatever, I mean, NBS has to be considered as part of the solution. Where it's slower even is on the private sector side of things, but actually that's moving as well. And as part of this Nature Hub session that we were in yesterday, our colleagues at ARUP, who I already mentioned about making gray suck less, they were also talking about how they are mainstreaming NBS in their engineering projects. And so as part of their whole early assessment of like go, no go on all of their projects, they're looking at how to integrate nature into those as well. So I would say they're an early adopter there. We still need to do a lot of work on the private sector side of things, but.
I was just in a really interesting panel right before this about essentially talking about regenerative agriculture almost as a nature-based solution. So
they talk about that in the climate space all the
Yeah,
time.
so-
Yeah, exactly.
No, I would agree with that. I mean, I think what you were talking about first sort of reminds me of Tony Slattery, who, you know, they don't know his whole big policy recommendations that one of my colleagues at the Water Policy Group is making is about the value of scaffolding at a higher level of government or a different level of government to sort of get folks to think about something they might not have thought about, and give them the political backing to maybe take a step they wouldn't have taken. And human right to water is an example I tend to use of a policy statement that had no teeth in it, that has led to inspiring activists, people within government and legislators to then do the numerous kinds of things to put money and time into it. And in NBS, the fact that people are being asked to consider it, I think really helps. This whole conference in putting water on deck is going to have implications that are intangible at the moment, but nonetheless profound as more countries start thinking about it. So there's power in those requirements to look at something or to say something. And the human right to water work in California very much came from Caterina de Albuquerque, the UN rapporteur on the human right to water, showing up in the Central Valley, helping elevate the issue, inspiring folks in the government agencies and folks in the field to do something. And the human right to water legislation was then passed in 2012. It was signed in 2012. It had been passed a couple of different times and vetoed by the prior governor, and it has led to a decade of billions of dollars and multiple things later. So that's the kind of soft power, or I don't know how to describe it, that makes a difference.
Totally, and also the states too. I mean, I guess in the U.S. context, I mean, the work that you've been doing forever on this and in this space, like it's I feel like there's some states that are really leading even the national governments and really pushing.
It really can be. I think the national stuff that happened here in the Biden administration is very, very important. California's work, which I didn't talk about here today, is stunning in what's going on. But then again, as Yogi Berra said, there's no difference between theory and practice. In practice, there is. But in theory, there's some amazing stuff happening in California on the nature-based solution side, both in integrating the air plans, some very different, the work in the natural resources and in Climate Smart California plan, all invoking water and multiple benefits. So it's a space to watch, and hopefully that was one of my paper to inspire folks in some of the other states who are kind of talking about. Well, we're getting close to the end, so I'm going to turn, if it's all right with folks in the room, to a couple of closing questions. I won't get to all the ones that I had. One quick one, maybe we can do them all fairly quickly going through the row. If you could wave a magic wand, I always love the magic wand question. What one or two things would you make happen right now in this space, however you want to define this space?
For me, I think I would say a cultural shift, to really across our entire society, valuing nature for its own sake and not making things all about us, because it leads to all of these approaches that undermine so many of the systems that support us. And, we don't value those, we don't account for those in our economic systems, et cetera.
Yeah, I haven't really talked about this that much here today, but along with the kind of cultural shift, also for the next generations, educational shifts, because the way that we're talking about engineering and policy and science and all this stuff isn't really, it's still very new, and it isn't being taught everywhere. I mean, I graduated from grad school not that long ago, and all of this, from my hydrology and engineering, it was still very much the stuff that was taught 30 years ago. And so I think that there's still, I think we need to really think about, mainstreaming NBS type work into education.
That's great. Great too.
So first I would echo these 2 points and add kind of 2 others rather than just single one.
You're allowed
It's
to.
two.
I think I said you could do 1 or 2. 1 or 2.
Okay. So in part, I would amplify the value of nature, right? So trying to continue along these nature-based solutions. Then second is to look at those as patterns to emulate where we can't necessarily restore, where we need to come in and do more active management. Central Valley of California, to me, is a perfect example of that, where we need to come in and think about how we get a network of natural recharge ponds. Well, let me rephrase, they're not natural, and a network of recharge ponds that match up both with the infiltration zones where we can store the water, but also where we think about natural contaminants that can really jeopardize the aquifer, and marry those 2 together.
That's great. I can see setting up a meeting with Rosemary next week. Yeah, that's great.
I would say if I can wave a magic wand, that it would be to kind of shift the way we're doing things to more of a systems-based approach, and to really emphasize the local aspects of how water is used and how it interacts hydrogeologically on a local level, and make all of that more visible, because I think that's often the trouble with like implementing projects and scaling them. And then I guess just to add on to that, really adding funding to that, particularly like the local projects. It's really hard to find funding. You need to do a lot of them across the watershed. So like having funders also think more in a systems way too would be what I would suggest.
Oh, great. I hope you get magic wands. That would all be really good. I would
Me
give them
too.
to you if I could. Okay, so final lightning round. You guys have been very good at brief answers for this, so we can do another one, which is a 2-parter, but short. What keeps you up at night, and what gives you hope?
We start on the other end.
Yeah, we can start. Is that right?
Yeah, I can start.
I
Keep
don't have Lucy start because she hasn't got the answer.
Yeah. Would you like to answer? Okay. Well, God, that photo of Jacob's Well. I mean,
Beautiful.
and right now but the one that's dry.
The bad one.
That is what keeps me up at night. And it's actually across the whole country right now, a lot of springs are running dry, and so that's very worrisome to me. Drought across the West is very worrisome to me. But I think what inspires me and gives me hope is being involved like with the local communities who are all coming together to really address those solutions head on, because they're really key to being able to do that. So, and I'm lucky to be involved in a lot of great efforts.
That's great.
Apparently I'm thinking in twos because I have 2 things that keep me up at night. And so one is the point Vanessa just made, is that we don't take a systems approach, and we, even in the nature-based solutions, we get too short-sighted and we think, oh, we can amplify those and really promote them, and we miss that there's another part of the cycle that is screwing things up. And so too much of a good thing, maybe. So that's
Too
one.
much.
Too much of a good thing. And then the second one is that we move too slow. Right, is that
Yeah.
on so many of these things that we start to, you look at California, Sigma is a great example, right? It takes 10 years of drought for everybody to kind of wake up and say, hey, we need to manage groundwater. And then you start moving down that and you get a really wet year like this year, and everybody goes like, oh, we're good, right? And then you slow down, hopefully not, right?
But they kept 2/3 after the last time we had a lot of flooding, so.
And so that's what keeps me up. And what gives me hope is that everybody in this room and elsewhere as working on these issues. And that I would say that the community engagement is really the part that gives me the most hope that we're going and starting to think about not just how do we engineer it, but how do we really work with communities to get these solutions in place. And I think that's really the hopeful future.
Yeah, I mean, for me, probably a two-parter as well as a Colorado native and former resident of the Colorado River Basin right now is a tough time there. So that is, yeah, definitely on my mind a lot. And also I have family that live in Salt Lake City, right next to the Great Salt Lake, which is another ecological ticking time bomb. So yeah, so definitely water issues in the Western US are a challenge. I think, more on the maybe the global policy space where I work, I think one of the challenges is kind of, yes, we're talking about nature a lot, but again, kind of, it's a little too wishy-washy for me. And so I do see some challenges ahead in terms of actually doing some of the implementation in an integrated, systemic way. I think that's definitely going to be a challenge. What gives me hope is a lot of the solutions that we're seeing. I know we focused a lot on the US today, but a lot of really great solutions, and we saw a lot of them yesterday in the Nature Hub as well, are coming globally and are coming from local communities that don't have a lot of funding, don't have a lot of resources, but are kind of taking initiative and doing it themselves. And it's really inspiring to see what they're doing.
Great. Okay, I have an answer now.
Thank God.
Thank you.
That's all enough.
Yeah, what keeps me up at night are projects that are continuing to destroy the remnants of the things we have left. Like, and San Francisco Bay, it's at risk of sea level rise. It's predicted to be like perhaps 5 to 7 feet by 2100, and yet people are still trying to develop like right on the coast. It's just crazy. Let's fill in more wetlands and build more stuff that's going to be subject to sea level rise in like 10 years. It's such short-sighted thinking. It makes me crazy. And then what Scott said about like nature-based solutions, like maybe being too short-sighted or too focused, that resonated with me because I think we have in our culture, in the dominant culture, such a tendency to want to optimize for efficiency. Actually, Ingrid's colleague, John Matthews, said something in the last session about the economy, but nature-based systems work because they're complex and there's flux, there's space for these systems to work. And so if we're trying to optimize trees as carbon sticks, then we're not looking at like the water footprint of trees and their role in the water cycle. There's like a million examples. Like there's a startup that wants to fertilize the ocean to get lots of kelp, and then they're gonna drag it offshore and sink it, and then the carbon will be stored under the ocean. And that of course is going to be sold as a nature-based solution, right? So stuff like that keeps me up at night. Hope would be like, so, I'm a journalist. I have covered the environment my whole career, and I have always kind of focused on, they're now calling solutions journalism. And basically my whole book is solutions journalism. I went around the world. I found people who were doing amazing things and starting to take them to scale. And there are so many examples, and people are learning more and more about how these things can work at, both the natural level, policy, economic, et cetera. And there's also a lot of amazing knowledge, traditional ecological knowledge, some of which I cover in my book. People who live close to the land and who have been in the same place for a long time really have brought close observation to bear. And that is an equally valid way of knowing things as our scientific method, which can be reductionist and sometimes miss the forest to the trees. I love science. That's a big part of what I cover, but science needs to work harder to integrate traditional ecological knowledge or like to acknowledge it as a valid way of knowing. So anyway, there's Yeah, endless stories of hope in my book.
That's great. Thank you for those. Well, thank you all. That was great. You covered a lot in a short period of time and you all did it really well. So thank you. And join me in thanking our panel. Out in the Zoomosphere for joining us today and enjoy the last third of the conference.
And thanks for putting this together.
Yeah,
thanks,
Felicia.
Felicia.
You did it. I'm happy. And thank you to EDF for the space and all the other things it took to be helpful to this possible. Really appreciate it. I'm sorry to spill water all over your carpet. Great. Enjoy the day.
Scott, I was gonna,
No, I was just gonna say, in a meeting yesterday with the UAE and other folks, the World Bank, as their like #1 thing that they wanted to talk about was aquifer recharge.
Outdated.
Which is super interesting. I was just like, oh, that's